to talk briefly about a few things, few sort of lessons from uh, the platformer make code. Did that stuff kind of make sense? Yeah. Okay. Uh, yes, sir.
I was kind of confused on like how to make the platforms and stuff like that. I mean, like how to like edit it and stuff. That was kind of where I was
Oh, the
getting
tile map part.
Yeah.
Yeah. So yeah, you handle all that through the tile map. And basically, right, so under assets, when you've got the tile map selected, then basically you just draw it like a map and it handles all the stuff on the background, which is really nice,
Yeah.
right?
So we're like, I was because I'm wondering how to like affect like everything about it. Like, I tried to add like one of those like blocks that like adds an enemy and stuff. And I really couldn't do that. I guess I don't know how to
Okay.
exactly.
Yeah, so like, well, because right now the way it's set up is that the enemies spawn, one enemy spawns at each exclamation point,
Yeah.
right? So what, you wanted to make another exclamation point?
Yeah.
Oh, well, then you just um yeah, well, where is the exclamation point?
Is it my
Oh, that's it, right. Yeah, click my tiles and then pick the exclamation mark and then we
Oh,
can
okay.
put another one. Um, did you edit the art for this or did you put an effect on it?
I might have an accident.
Okay. Oh, no, it's okay because you see how some of them are kind of pinkish. But well, let's just run that and see if it works. Right. One. Yeah, there we go. Okay, I'm not sure why they were showing up pinkish, but yeah.
Did it like look different? I wasn't really sure about that.
Yeah, that part I'm not sure about why some of them looked pink. But whatever. I mean, it doesn't look like they actually look pink. Yeah.
Another issue was I think the tutorial didn't really tell us how to make the enemies go down.
Yes, it didn't.
How
Okay.
do we do that?
So you either had to figure that out yourself or, right, because like let's look at the enemy code, right? So there's this bit, yeah. So you see how the cats are getting stuck against the exclamation mark block? Well, that's because we haven't told them what to do, right? And in this case, they're not in any way influenced by gravity, which we'll talk about that. Um, and So all basically we're doing is telling it how to do stuff in sort of a a horizontal direction, uh, which is, uh, well, actually, no, vertical or horizontal, right? Because we got this. If you're touching a wall on the left, move right. If you're touching a wall on the right, move left. Okay. If you're touching a wall on its bottom, that would mean that like you're touching the underside of something, then move down. But the movement, so like the cat is running into a wall, right, or a tile, um, and it's not going to do anything in the vertical direction unless we tell it to, right? So like here, uh, if it's hitting a wall on the left or the right, then move the opposite direction. We could actually add something here that makes it also go up or down a little bit. That would could change that. Okay, but it's up to us to do that, right? Um, okay. So, on the subject of physics, I did want to talk about that because that was a little confusing to a few guys. Um, let's remind ourselves, what is the coordinate system on the screen? Where's the origin? Top left, okay? Which direction is the positive x-axis?
Up, up the screen.
X.
Oh,
Well, okay, yeah, I see what you mean. Like, which direction is the x direction? Left, right, correct? All right, which way is the positive x direction? To the right. Okay. So, and that's just like it is in math class, right? What about the y-axis? That's the annoying one. The y-axis, positive y runs downwards, not upwards. Okay, so all the y stuff is backwards from what you would maybe expect in a math kind of situation. Sorry, right? Just the somebody a long time ago made that decision, and we've been dealing with it ever since. Okay, so if we look at the player's physics stuff here, right? So like, where's the bit where we hit the here it is, where you hit the A button, right? Uh, it sets the velocity to minus 200, which you might think means that you're going down, but actually you'd be going up, right? Because the y-axis is backwards from math class. Okay, good. All right, now the other thing I want to talk about though is what kind of physics do you have control over potentially for these characters? So when I jump, if I hit the B key, right, what happened to the player, which Ryan decided to make it a shark? Do, 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 do. No. Baby shark?
I don't know if that sounded like Baby Shark.
Yeah, I know. I think I mixed I wanted to do Baby Shark, but I ended up doing Phenomenon.
Yeah, that's probably.
Okay, so uh, yeah, sorry. How does it go in Baby Shark? Do do do. No. Okay. Yeah. Do any of you guys have little brothers or sisters? Yeah, that are all into Baby Shark and um, what's this character that they killed off that every parent is super happy about? Kalilu or something like that? Caillou? That's like super whiny brat. And anyway, I just saw that on the news the other day that parents are rejoicing. Um, okay, so anyway, the sets the velocity to minus 200. Now, why is it that the shark comes back down eventually? Right? Why is it falls? What controlled that? There's nothing here that says to go back down, right? So what's doing that is right here, the acceleration. Okay, so this is a calculus thing, but what's the relationship between position, velocity, and acceleration? So position is where, yeah, that's the calculus term for it. Position is where you're at. Velocity is how fast that is changing. Acceleration is how fast the velocity is changing. Okay, so if we have an acceleration of 500, okay, which direction is that? Which way are you accelerating? Downwards, okay, because it's a positive number, right? Again, the y-axis is backwards, okay? And so what is it modeling here? To have a constant downward acceleration, what are we trying to model? Gravity, okay? Now, 500 is some number, right? Is that meters per second? Well, no, right? This isn't like, what is a unit here? It's probably 500 pixels per second or something along those lines. Um, but yeah, so it's just whatever number. And of course, you could tweak that, right, and make it like moon jumping or something if you wanted to. That might be kind of cool for a second level or something. Okay, but so what's happening when you jump? Your velocity is at that instant minus 200, and then the game engine is doing the physics to say, okay, there's an acceleration being applied to you as you move upwards that's decreasing your velocity, and then it turns it back around. And then you start falling back towards the ground until you hit one of the blocks, in which case you're not moving anymore, right? That kills your velocity. Okay, does that kind of make sense? Now, the thing about the physics of this is that notice that this is for my sprite, his acceleration. And in this case, my sprite is just what Ryan called the player's character. Obviously, it could be called anything else. What does that mean, though? If I set the my sprite or the player's acceleration to 500, does that affect any of the other objects, Mr. Troy? Yeah, exactly. Each object can have its own acceleration. Okay. Now, if we wanted to make them all subject to gravity, we would make all of their accelerations probably the same number. Okay. Um, and but it's not like we necessarily would have to do that. Um, now, in this case, we're using acceleration in a vertical direction to model gravity. Okay, but that's certainly not the only kind of acceleration you could have, right? Let's say we were making like a race car game or something, right, then the acceleration would be in whichever direction you're facing, and it would be subject to the throttle on your, or the gas pedal or the brake pedal. Okay. Um, so the acceleration can have a uh, two directions, right? The x direction, the y direction, independently of each other. In this case, right, gravity goes down, so that's why we use the y direction. But it's a property of a particular kind of sprite. Okay, so every sprite of the kind player, or sorry, um, you can. So we could have multiple sprites of the same type, but each one with a different gravity, right? So here there are 4 or however many cats, the enemies that are created, right? And those are all set here, okay? Um, you could make each cat have its own different value of gravity. Now, I don't know why you would want to, okay, but theoretically you could, okay? Um, or maybe better is the cats all have a particular velocity that they're able to move at. Well, maybe you want to have like another type of enemy that can move twice as fast. I don't know, right? Um, that's sort of a design decision, but these are local to each sprite. Okay, does that kind of make sense? Yeah. The other physics that you have control over, so if you hit the little drop down, you can see these are all the default local variables for each sprite. And we talked about, I think last time, how you could do extensions to add your own local variables with the data extension. But the ones that are built in are, all the physics ones are at the top. So position, velocity, acceleration, and then there's also one down here for friction, which we haven't used. But you could imagine, for example, like let's say that we had a world where some of these tiles were made out of ice. Okay, then you could set the friction to be a different amount on that than say on uh, just like this grass stuff that Ryan picked, or the bricks or whatever, right? And then that would modify like whether or not you sort of slid when you stopped moving, um, by controlling the friction. And different things could have different frictions. So you could say, okay, if I'm touching a ice block, set my friction to be one value. If I'm touching a block of molasses or whatever, set my friction to be something else. Okay. Uh, yeah, good. Okay, so those are the things. Then you've also got, and you guys use these left, right, top, bottom for the collision stuff, because let's take, for example, the exclamation mark, right? Or actually the enemy. What happens if I touch an enemy? Yeah, I lose a life, but not under every circumstance, right? Yeah. If I hit the top of the enemy, then I don't lose a life. Okay. So if I touch an enemy, in all circumstances, the enemy gets destroyed. That was a design decision to program it that way. It doesn't have to get destroyed, but it does. Okay. In this particular example. But we've programmed it in such a way that you don't lose a life if you touch the enemy from the top rather than from the sides or from the bottom. Okay. And um, that, I mean, that kind of makes sense, right? So think about, or like, let me back up. Makes sense from a game design decision, right? So there's a game design decision, and then there's actually implementing it in the programming. And we kind of want to talk about both. So in the programming, how did we do it? Here, okay? It's if the sprite's bottom is less than the other sprite's, the enemy's y coordinate. Okay, now of course we got to think about the order of the inequality here, right? My sprite's bottom being less than the other sprite's y coordinate means I'm actually above the thing. Okay, but also the other sprite's y coordinate is actually at its center, not at its top, right? So that's the difference between x, y, and top bottom. Is your xy is the center of the object. your top and bottom would be the top or bottom of the object. Okay, that makes sense, right? And it'd be useful to be able to keep track of those. So I think strictly speaking, if you're real good with the controls and you kind of touch the cat like at the very top left of it, not from the top, but sort of just from the side, the very tip top, it still will register as a you hitting it from the top. Okay, does that make sense? And maybe that's what you want. Maybe that's not what you want, right? But that's a design question. Um, okay, so so does that make sense then? How that worked, right? And in this case, we wanted it so that when you touch the enemy from the top, you don't lose a life, and otherwise you do. Okay, how could we use this to make the little exclamation mark block do something cooler? Like, what could we do there? Yeah, you could, okay, but in terms of the touching it part, right? Like, I mean, you could make it spit out a coin every 30 seconds just for giggles, right? But think classic Mario, right? What happens when you run across a block that's got a question mark on it? Well, it depends, right? So if you jump and hit it from the underside, okay, and if you do so, then what happens? Like it releases. I mean, think of the very first one you run into in Mario Brothers, the original Mario. What happens? Yeah, the mushroom, right? That makes you big. Okay, but then on the subject of that, like, what happens if you in classic Mario you hit a brick from the underside? Yeah, it breaks only if you're big. If you're little Mario, then it just sort of does the boom thing, right? In fact, let's just want Mario, the original. Here we go. I would be amazingly happy if I could make that nag thing about the free trial never, ever, ever appear ever again. If anybody knows where in some setting I can do that, because God, that is annoying. All right, let's get to the actual. I don't care about your stupid intro. Okay. All right, so, right, what happens? You guys can't hear all the sound effects. Uh-oh. Well, okay, whoever's playing this needs to be smacked because he needs to, like, break a brick already. All right, well, whatever. Right? You guys all remember this, right? I remember. No. Remember Barry's South Park? Okay, some of you get it. Whatever. All right, so yeah, so we could make the exclamation mark block do sort of like that in classic Mario, and this would be the kind of thing that we would be doing is saying, all right, which direction or which side of the thing am I touching? You could also, by the way, make it if we had a either a global variable or a local variable. I don't think it would matter in this case. To have like big Mario versus little Mario, right? You could do that, right? And then say, okay, if I touch a block from the bottom and I'm big, then break it or something, right? Okay, does that kind of make sense? Yeah. All right, let's see what else that I want to talk about here. Oh, the other thing was, oh yeah, I remember now. So you see how we're using this start next level thing as a function? Okay, so a function in this particular example is just this dark blue block just represents all of this stuff. So it's like a shorthand, right? It almost would be like you write a program in a notebook, you close up the notebook, and you slip the notebook into a bigger program, right? When you hit the notebook, you open it and you go through it page by page, you do everything, and then you're done, okay? So function in a computer science sense has a slightly more general meaning than function in a math sense. All right, so what's a function in math class? Yes. Okay. So say something like f of x equals square root of x. Okay. So what makes that a function? You put in a thing, it spits out a thing. Those things are in math class usually numbers. Don't have to be. Okay. But and maybe you put in 5 numbers and you get back 1 number. Or maybe you get back like a list of numbers, so a vector kind of quantity. But you put in things and other things come out. This is an example of a function here, this um, start next level. Did we put anything into it? No. Did it return any values to us in the sense of like square root of x? Also, no. Okay, so function in computer science can just be a list of instructions. It can be a list of instructions that returns and accepts numbers as input or output, but it doesn't have to be. Okay. In this case, there's no input or output for the start next level. Um, okay, so for the sake of this particular program, all it's being is a shorthand for a big chunk of code. Okay, now within that chunk of code, there's a few different things. So this was handling basically how to change from one level to another. Okay, so what happens when you call this function? Um, it destroys any enemies that are already on the screen, okay, so that it would recreate them, right? You don't want the enemies from World 1 to be still hanging around in World 2. Okay, that'd be kind of silly. Um, but then what does it do at the right after that? So that's that first red block. Change current level by 1. Okay, so what's the idea here? What is the first level? What's current level for that? Well, okay. What gets me the first level? It'd be this block here, right? So if current level is 1, that's the number I'm associating with the first level. I mean, it's a logical number to associate with it, right? And if I'm on that level number, then I set the tile map to be something and the background to be something that I've chosen. Okay, basically set the art for the level. Okay, good. And if it's 2, then I do something else. And conceivably, we could have any number of levels, right? You can make 50 if you wanted, and have different tile maps and different backgrounds and different stuff for each one. There's just 2 in this case. Okay, does that make sense though? So what is the starting, when you run the program, what is the starting value of the variable current level? Huh? Is what? I'm sorry, 1. Is it? It's actually 0. Okay, and the reason that it's 0 and not 1 is because to get to the first level, we change it by 1. So if I get to 1 having added 1 to something, what did I come from? Had to be 0, right? Okay. Did we ever tell the program to make that the initial value? No, we never did. In fact, I'm kind of surprised that the function ran or the program ran at all. Okay, because So this depends on the programming language. Some are much more picky about this than others. Python is pretty forgiving about not setting values of variables. So in C or Java, you can declare the existence of a variable without saying what its value is. Okay, and those two things are sort of separate. But if you declare the existence of a variable and then you try and use it, but you have never told the program what its value is, it'll croak. Python's much more forgiving. What's the default value probably for any numeric variable? 0 makes sense, okay, to be that thing. But to be clean about it, what we really should have done is put one of these at the very beginning to manually set that